Hi everyone, this is just a quick follow-up on understanding the command line. Just want to give you a bit more information around files and directories. And there are some special files in the home directory we should discuss. Also, there are some ways to customize your command line, which you might find really useful. And finally, there are some utilities which will really help, and they do give you quite a bit of power. So I think it's worth just covering a few extra things. Okay, so here we have bash in front of us again, just like last time. Now, one thing, I sort of brushed over this last time, but this is where it's worth just covering on a little bit more detail. So if I look at where I am right now, I'm in my home directory. Now, /home/wasm is not a, well, it's a directory, but it's a path as well. So that /home/wasm, that whole string is not the name of the directory. Wasam is the name of the directory. /home/path, sorry, /home/wasam is a path to get to the home directory from the root directory. So a path, it's worth just making that clear, that a path is a fully qualified name that explains how to get from the root directory all the way to a specific directory. And because it's specific, it's unique, right? So if I started from the root directory, right, cd/, then I can use, I can sort of navigate my way to that home directory by changing into the home directory. So this is one directory at a time. And if I do an ls in here, you know, we have directories in here. We looked at that before. But the point is, I'm now in /home. That's the full path to the current directory at the moment. And what I'm doing by going into cd into wasam is I'm one step at a time navigating into wasam, which is of course my home directory. Right. So what does that mean? That means that a path is a way to get to it's just like navigating a map. It's a way to get to a specific point. So, and like any specific point, it should be unique. So what does that mean? It means that you've got relative paths and you've got full paths. So /home/wasam is a full path because it's specified from the root directory. Now we had our testdir before. Now, for instance, if I go back to /home, from here I can go straight into testdir by providing a path that's relative to the home directory. So for instance, I can just list it to find it and identify it if you like. So I can go wasam/testdir, and notice that this starting from wasam with the slash separator and then testdir, that's specifying it's a partial path. It's a path relative to the current directory that will find me or navigate me to testdir. So if I hit enter, sorry, well, it's empty, so ls shows nothing, but if I cd into that, okay, and the slash at the end doesn't add any extra information, so you can take that off, it makes no difference. But now I'm in testdir, right? pwd, we see the full path is /home/wasam/testdir, but I'm now in that directory, and it is a child directory to my home directory. So in the same way you have a hierarchical or family type relationship that you see in other places, like in families, right? Parents and children and grandparents, that kind of thing. That kind of hierarchy is also found in directories. So testdir is a child rather of wasam. Wasam, which is my home directory, is a child of home. Home is a child of the root directory. So we have relative directories. Now, if I want relative paths, if I want to go back one directory to the parent of testdir, which is wasam, then I can use double dot. And double dot is a name referring to the parent directory. Now, the other thing is I can see double dot in the current directory. If I do ls-la, I get, the A means show all. Normally directories or files that start with a dot are hidden, and they're hidden just to avoid clutter. But the thing about it is dot means the current directory, so you can see here there's this highlight on this current directory dot, and then there's double dot. Oh, that doesn't highlight well, but double dot there, and that double dot means the parent directory, so single dot means the current directory. So I can do cd double dot. Now where do you think that's going to take me? Right, the parent of the current directory, which is wasam. And if I do pwd, I'm back in /home/wasam. And we can see in the prompt it's showing you that tilde, which of course means my home directory. So now we've understood a bit more about relative paths and full paths, that you can cd up to the parent using double dot, and that we have this concept of relative versus full paths, which can have some real use. Okay. Now let's look at how we remove directories. We talked about it last time, but we talked about removing one directory, and we talked about using rmdir. Now rmdir will only work on an empty directory. So this is another reason why I wanted to do a follow-up, because you might have tried it and it probably would have failed, because most of the time when you have a directory you have something in there, and so you probably were thinking, well, hang on, Warwick said I could use rmdir and it's not working, so what's happening? So for instance, let's create a new directory under tester. So I'm going to go back into there, and we'll make a directory called delme, as in delete me, but this time we'll put some content in there. Okay, so I've just reconfigured my terminal a little bit to make it fit for the video capture, so it's a bit easier to read, but also the text doesn't fall off the bottom. It was doing that a bit before. Okay, so what do we have? So I was just explaining that I need to create a directory called delme, and if I put some content in delme, which I did just now, if I do an ls in delme, it has content. So the point was, if I have content in there, I probably can't use rmdir on delme, right? Because it's not empty. So that's to protect myself, right? To stop me from making a mistake that I will regret later. Because if there's content in there, probably I don't mean to delete the directory. Although sometimes, I'm the user and I do know better than the computer. So if I want to tell the computer that I want to delete the directory and all the content inside it, and any children directories and all the content they might have, so this is blow all of that away, then rm-r means recurse or repeat. It will repeat through all children and children of children's and take out all directories and all files that are under delme. So I can do this and it doesn't complain. Also, it has done the job. So delme is gone and content is gone, and all of that is now erased. So it's good to know that rm-r, the -r option, will help you get rid of a directory and any content. Sometimes when using tools, you'll end up having a directory that'll have subdirectories, and that they'll have maybe more directories, but they'll have content in them, and it gets created by some of the tools when we're working with JavaScript, particularly with npm. So if you want to reset things and get rid of those working directories, you need to know this. So that's why it was worth covering off a little bit more information. Okay, so that's the -r option on rm. Now we've started talking about paths and how you've got relative paths and you have full paths. So one reason why that's useful to know, apart from being able to identify something uniquely and specifically, and also of course relative paths are very handy, just being able to say up one to the parent directory, or if I make a subdirectory subdir that I can I can copy. Well, basically let's just say I can talk about children or parents directories in a relative way, as in relative to the current directory, and I can do work that way. So that's very helpful. having both full paths and relative is very helpful. But sometimes you need to know where are the programs being found. So bash is a program, and you might want to know, well, where's that? And which version of that? Like sometimes you might have multiple copies of the same program, or rather different versions are installed. And so you want to know which one's being used when I just type in some command, right, or some program. So for instance, there's a program called file, and file is very useful because file will tell you what type of file something is. It'll even tell you, identify something as a directory. So that's very useful. So for instance, if I do a file on subdir, it says it's a directory. And if I go back to my parent directory, there's a package.json, which is a text file. And if I do file on that, it will tell me it's ASCII text. In other words, it's just text. So now the thing is, you might say, well, so that's great. There's a program called file, and I can use file. Where is file? Right? Where is that installed, and which one am I using? Say if there were multiple versions of file installed. So I can use the program called which. So I say which, and then give it the name of the program, and it will tell me this is the full path to file, including that program's file name. For instance, there's NodeJS, right? So if I do which node, it will tell me where that is. Now, here it's giving you back a full path, so that's good. Now you might ask, well, how is it finding those programs that are somewhere on the disk but not in the current directory, right? So I'm now in, right, pwd, I'm now in my home directory, /home/wasm, /user/bin is a completely different directory. So how does it know to find those programs in that directory? Okay, there is an environment variable called path in full caps. So if I do echo $path, and you might remember from last time, I can do echo and then $environment variable name to get the value. And here we have the content of the path environment variable, and we can see that it's a long list. The list is broken up by these colons, okay, and it's identifying different paths where programs can be found. So for instance, if we take just a couple of these and just do an ls to see what's in them, so what do we have? We've got user local sbin /user local sbin, oh, that one's empty. User local bin is another one right there. So let's try that. And that has a couple of things in it. There's user/user bin, which is where node and file were found. So if I do ls/user bin, and that's got a lot of programs in it. So the point is that environment variable is very helpful, and sometimes you want to add a new program and it can't be found. And if you want to run that program, then you might want to customize your shell. And so that's why it's good to know about the path environment variable. So we'll talk about how to customize the shell environment a little bit later, the command line environment. But just wanted to point out, we've already talked about paths, and now there's a path environment variable in all caps. And what it means by path is it means what are the paths for the binary files. That's why it's called path. Okay, so now let's see, what else was I going to talk about? I've got my cheat sheet over here that I'm just looking into. So we've talked about paths, we've talked about slash as a separator between those file names, the directory names making up a path. We've talked about RM, we've talked about which. Right, move was the next thing. So you might be wondering, can I rename something, and also can I move it about? Now, the way they do it with the bash commands, move is the one command you need to rename or to move something. So let's go back into tester and let's see how that works. So we have subdir, which I created before. I can create another directory, and let's call it, we'll call it new child of sub. Okay, and then let's say I was trying to make a directory and put it under subdir, and then I realized, whoops, it's in the current directory because I forgot to put subdir slash in front of it, right? So we've talked about relative paths. Makedir takes a path actually. So if I want to make a child of subdir, then I would do this: child of slash. Oh no, hang on, go back. Starting to think in reverse. Subdir slash child of. Right? If I do that, it's not in the current directory. If I do an ls as subdir, we'll find child of in there, and there it is. So makedir and actually all the tools will take a relative path. Okay. So the reason why I bring that up is now new child of sub is in the current directory, and actually I want to put it in subdir, so now I'm going to use move. So move, and it's original relative path to destination relative path. Okay, so I can do that, and it means, it's referring to that directory, new child of sub. This would work for files as well as directories. And now I can just put subdir slash, and it means take that directory and put it under subdir. Now if I do an ls, it's no longer in the current directory. If we ls subdir, it should have two directories, right? And it has child of and new child of sub. So that's move working as a move function. Now what I can do is I can also use move to rename. So let's do it with a relative path. Okay. So from the current directory, I'm going to rename child of, which is in subdir. So I can do that this way: move subdir slash child of. So that's a relative path to child of, and let's call it pet of, right? Like it's a pet, like a pet cat. So subdir slash pet of. So what I'm doing here is I'm keeping the parent the same because the parent's listed in both. But I'm changing the name, right? I'm taking that item, which is the directories, child of, will now have a new name because the final path has that last name, that last overall name of the path has a new name. So if I hit enter, we do an ls on subdir, we have pet of along with new child of sub. So new child of sub was not changed in any way, but pet of was, which used to be child of, now has that name pet of. So we can move things, it doesn't have to be in the current directory, we can move things, say, out of the current directory or into the current directory, or somewhere else altogether, and we can also change names. And you can see that it's really dealing with the concept of path for that, which is why they use move in both cases. So now you must be starting to think, well, I can move things in relative directories. Can I move them with a full path as well? Okay. So for instance, I can take pet of. There's a temporary, there's a directory for putting temporary information, and it's stored under the root directory. It's called TMP. So if I do an ls slash TMP, we can see there's lots of, these will be temporary junk working files of the operating system or other things. So what I can do is I can move pet of out of the subdir and into /temp. Okay, so remember where we are right now. We're in /home/wasam/testdir. We have subdir and we have subdir /pet of, and so I'm going to take pet of out of that being a child of subdir, and I'm going to move it straight into /temp. So move, sorry, I have to do subdir /pet of, right? This last slash doesn't do anything, so we get rid of it. I could leave it there, it just really doesn't make any difference. Into /tmp. Now that's all I need to do, right? And if we do an ls on /tmp, we'll find pet of is there. Now let's bring it back. Okay, so move /tmp/pet of back into subdir. Right now, this is subdir is a relative path to the current directory, and if we do an ls, it's not in the current directory. It is in subdir, exactly where it was before. Now let's try one other thing. So if I go back to that command, and if I do pet of at the end there like that, well that, sorry, wrong one. Where are we? I'll type it again, never mind. What I meant to do was take pet of out of subdir and move it to /tmp, but specify its name like this, because remember last time I did it this way, where I just said take pet of out of subdir and move it into temp without specifying a new name or what that path will be at the end of it. Here I can use the same name to specify what the path would be at the end of it, and if I do an ls on /temp, it's still called pet of. Let's move it back again to show one more time something else. So /temp/pet of, back into subdir, ls subdir, it's back there. So again, back to how it was. Now, can I move it into /tmp and change its name in one action, right? And the answer is yes. So if I do move subdir pet of into /tmp/ cat of, as in cat is a type of pet, no complaints. And if we do an ls on /tmp, sure enough, there is cat of. So we have done a move and rename in one action because we have moved its path, right? We've moved its relative path to from one place to another place, and because we've changed that path, it's also picked up a new name. Okay, so let's move it back /tmp/cat of to subdir, and I'll rename it back to pet of. And let's have a look at subdir, and it's called pet of again. So there we are. That's how we can move things around and how we can rename things using the one command being move. And because it's all about moving in relative or full paths, that's why that all makes sense. Okay, that's the logic. And it's always from to in terms of the order. Okay, now the other thing that's worth mentioning is you've got, if we do ls-a, we can see, or ls-la, I can see a long list this way. So we've got the current directory as a dot, we've got double dot being the parent directory, and then we have the subdirectory subdir. Now I can take pet of, and I can move it into the parent directory using the double dot. So we can move subdir pet of to double dot, which should be the parent directory, which of course will be my home directory. So if I do cd tilde, the short name for home, and do an ls, there's pet of. So double dot works as a reference to the parent directory, which we've just proven, and that's something true wherever you are. So I can, let's see, what's a good example of that? Let's go into tester, and let's make a sequence of directories, and you can sort of see how this works. Make the d1, and then I make the d1/d2. So now if I do an ls on d1, we can see there is a d2 in there. Now I can move from the parent directory, take pet of, and I can drop it into d1/d2. Okay, let's ls d1 d2, and sure enough pet of is now in there. And let's cd into /d1 d2 ls, and we can see pet of. If I move pet of to the parent of the current directory, it should go from d2 to d1. do an ls, nothing's in D2 anymore. Use cd double dot to move into the parent directory, do an ls, pet.of is there. Let's move it again. So I can go back using the up arrow and find move pet.of double dot, right? And this will take it out of D1 and put it into, what was it, subdir? No, testdir. Right, so now if I cd into double dot, I'm back in testdir, which is the parent directory, and pet.of is there. And now if I want to remove D1 and D2 together, of course I should use rm-r, but just to show you, even though the directories are empty, they don't have any files in them, I still can't use rmdir on D1 because D1 has D2 in it. So it still thinks a directory is kind of content as well. I can do rmdir d1/d2 because D2 is empty, right? That works. And now I can do an rmdir on D1. That's why the -r is handy, because it saves you from having to kill everything right down at the bottom, you know, children of children directories first and then come up manually. You can do that with the rm-r. Okay, so we've just covered a whole lot right there. So the ability to recurse or repeat with rm, we've talked about which, we've talked about file, we've talked about relative paths and full paths, we've talked about being able to move things around and rename them. So that's pretty good. And we've talked about hidden directories with or hidden files. You know, anything with a dot in front is that hidden file. So that's pretty good. Now let's talk about what we find in the home directory that is special. Okay, so cd tilde takes me back to my home directory. If I do an ls -la, I get that long listing, and because of the A option, I get everything or all things, including anything with a dot in it. So we can see right at the top there's a single dot for the current directory, which is now the home directory. I've got double dot, meaning that's a reference to the parent. So the parent of /home/wasm is /home. We can see it's got a different, this is talking about ownership. So I own my home directory, I always do. This is my user. But root, which is like a user of the operating system, it owns /home, which means I can't delete /home, which is a good thing. Okay, now we have a number of files here, as well as some directories. So /bashrc is a special file. RC kind of means resource control or something like that. You'll see this with Unix systems that they'll have .rc files for things. And so I know it's a file because it doesn't have D over here in this long listing. I'll also know it's a file if I do file on .bashrc, right? It tells me it's a file made up of ASCII text. But this file is an interesting file because it configures the command line, right? The bash command line. So if we look into it, now I can use the less program to look into it. Less is a bit of a joke. The name is a joke. The original name in Unix systems was more, and less is the more with more, so they called it less. It's a joke. But the point about less is I can use it to kind of page through a file. So here we have the bashrc contents, and I can hit space and page through it. The original Unix more would only let you page through it and pretty much just end it, quit at the end of having paged the whole way through it, and that was all you could do. With less, you can go back and forth and use arrow keys up and down, and it's much more flexible, which is why it's the more with more, and they called it less. Okay, so let's have a look at this thing. So from the very top, now I'm not going to go too much into the details, but just so you know a couple of things. A hash is a comment. So bashrc is actually a script. It's kind of like a bash program. You can write bash programs just like you can write JavaScript programs. And so this particular file is a program that configures bash when you run it in your home directory. So what it's doing, what we have here is just some comments, and the comments just try to give some useful tips on what each part of the file is doing. I'm going to ignore most of it. Let's go down. But there are some things which you'll find useful. We're not going to worry about troops. We are going to worry about fancy prompts. You might have wondered, well, how did I get that fancy color on my prompt? The Mac environment doesn't typically give you that fancy prompt, but it's fully capable of doing it because it's something that's driven by bash. So the thing is, you just need to configure it to do so. So you can Google these things to find out how to get color prompts in bash. But where would you put that configuration? You would put that in the .bashrc file. So, and that file has to be in your home directory. So here, what this is basically doing is it's saying term is a kind of term is an environment variable, and xterm color is a type of terminal program actually, and it's one that supports color. They don't all support color. So because that one supports color, it's going to essentially say color prompt equals yes, so that's setting an environment variable for bash. And then later on down here it's saying, well, if and there may be another option to force color prompt, and then down here it's saying if color prompt is yes, then this PS1 environment variable sets what the PS is, I forget exactly what it stands for, but it's basically it's talking about the shell. The S means shell, and bash is a type of shell. So here it's getting a well, we don't have to worry about Debian root. That's just where the root directory is. But here, because remember in the prompt it'll have user and it'll have the current directory. So this is how that is configured. So these crazy values here are actually configuring prompt color and prompt, what would be presented in the prompt. So if I quit out of this for a second, it's actually configuring this. Okay, and the color will come from the green. Those codes will also have green, which is what this \033 one of these things is referring to. It'll be a color code. So it's not as nice as CSS or anything like that, but the point is you can configure it and you can get these values by Googling them, and you can configure them in your environments because it's nice to be able to make things how you want them to be. So that's a bit of a curiosity. It's not the end of the world or the most important thing to know about, but sometimes it's good to get the prompt with your current path, current directory. But one thing that is super useful is the ability to set aliases. You can use an alias. So why the ls is giving me color codes to represent what a directory with a green and things like that. It'll be because ls has been aliased to mean ls -- color equals auto. So if I copy this, quit out of it, and then okay, that didn't work. Do that. We can see that I'm getting these colors back. If I do ls -- no, that didn't work. I was thinking that might override from the color. Anyway, the point is, it's the alias that's actually giving the that's configuring the colors. Let's have a look in here. So we can see in this file that aliases are being set if colors. Okay, so basically, if colors are supported, then an alias is being set on ls to then give color output. Let's not worry about the details too much, but the point is aliases are being used in a conditional way. But here, aliases are being set up always. So this is a pretty common shorthand actually. LL for like long list. We'll use ls - AL, which you might remember from before. The F is just another option, but AL meaning all files, and the long listing. And so these aliases are just shortcuts basically. And so you can create your own alias. And you can do that just by adding it to this .bashrc file. So you can edit that with TextMate or something like that, any text editor. You could even use VS Code, Visual Studio Code. Okay, so now we've talked about special files and the fact that we need to use -a to see them. These special files in your home directory, and that bashrc is one of them. The other one I wanted to point out just quickly is bash history. You can actually find out the history of the things you've typed in your command line by typing history, and you can see that's just going on forever. There's a way to use less to make that page through bit by bit and see that one bit at a time. But the point is, you get to use the history with up and down arrow keys, and I'm getting that bell you can hear when I hit down and I'm at the end of the list. There's no further I can go, so it's just kind of telling me off. See, hitting down. So it's very useful to be able to edit previous commands to, like I can go up, find this less bashrc, and I can hit enter, and I'm just repeating that command, or I can edit it and make it something else. Okay, so we've talked about bashrc, we've talked about history, the bash history, and how we can use the up and down keys to see it. Now, one thing I wanted to talk about was shell programs, and I mentioned that the .bashrc is a kind of shell program or bash program. Now, I'm not going to explain too much how to write these because it's a whole lengthy video of its own kind, but the point is, if I just quickly use VI to write a eg.sh, the point is that bash programs, shell programs, tend to end in .sh. It's just a convention. They don't have to, but they often can. The files I'd set up for you guys, setup-laptop.sh and setup-monash.sh, are both bash programs done exactly the same way. So I can now I'm editing this eg.sh, and I can put commands in here. Now remember echo, which can be used to show environment variables, but I can use it to just show a message like, hi there. It's always nice to be friendly. Now I can write that out, write and quit, and I can execute that by typing bash, then eg dot, and it runs it. There are some other tricks we can do. I can actually make it executable and it will work just like a regular program. So let's do that, and I'll show you a couple of things. And we can use this as an example for the whole path environment variable that we talked about before. So one thing is, to make it executable, you might remember when we do an ls-l, we see these special codes meaning properties on a file, like if it's D, it's actually a directory, and if there's a dash, it's not a directory. There's another property called X, and X means executable, like a program. To make it executable, we have to do a couple of things. I need to tell the bash environment that this file is an executable, and then I need to tell it which interpreter to use. So for instance, I could use Node and write a JavaScript program, and it would know how to interpret it. Or I can do this and make a bash program. And so I can do that with /usr bin bash, and what that is giving a full path to the bash interpreter. So really that hash makes it a comment, exclamation mark means interpreter specification, and then the full path to the interpreter. And then we have our commands, and I could have multiple commands. So I can make this another message, and again I can type correctly, and I'll get rid of that dash, and let's write that out. And now the way to change attribute, let's have a look at the long listing for EG, and we can see it's just read write, and it's just a file, it's a text file. If I do a file on it, EG, just a born again shell script. So born again shell is bash, and it's a shell script, so it recognizes that much. And now if I do a change mode, chmod, plus X to make it executable on EG. Now when we do the ls minus L on EG, we can see it's got these read write X for execute, read write X, and I can now execute it, but I need to give it, if I just type eg.sh, it can't find it because the directory I'm currently in, which should be my home directory, is not in the path. If we look at, if I echo $path, I'm not going to go that bit by bit, but if we were to read through this bit by bit, we'll see that you know, /home/wasm is not in the path. So it doesn't know how to find it. What I can do is I can give it a full path to eg.sh, like /home/wasm/eg.sh. That should work. Okay, that's fun. Why not? Okay. Hang on, let's do a which bash. Right, I've told the interpreter spec in the EG file is wrong. That's why it had an error. So I had user bin. If I get rid of /usr and just make it /bin/bash. Now if I go up and do this, why? What? /eg, that should work. That does work. home/eg. That works. Right. Oh, it was am, that's why. I misspelled my full path. M? Right. So a full path to this new program I've created, it can execute it. When I do // as a relative path, remember dot means current directory, that also works. And $home is a variable that has my home directory, so that equates to being a full path, basically, because $home is a full path to my home directory, and then by putting eg.sh, that all adds up to being a full path to that program, so I can run that. So let's add it to the path environment variable. What do I have to do? I need to add my $home, effectively, to the the path environment variable. So I can do export path. In fact, let's do it without export. So path equals $path. Remember, $path just means give me the value of path. I need to add a colon because that's the separator between paths. /home/wasm. And now if I do an echo $path, is it right at the end? It's right at the end. Perfect. So now I can just type in eg.sh and it works without having to give it / in front or anything else. If I have a look, we still have tester. If I go to tester from here, can I still do it? eg.sh, and I can. And that's because now it knows where to find eg.sh using the path environment. In the path environment variable, we've added my home directory, which is the directory that this program's in. So now it can find it. Doesn't matter what the current directory is. So that's how I've extended my my shell to know about that. Now the thing is, if I quit the terminal and then start it again, that setting for the path is gone, because that environment variable is just set once in memory. It's not stored anywhere. So I'd need to add it to the .bash file. So I can do that. Now I need to do it, say, because I'm in tester, I'm going to edit it using ~/.bashrc. Remember, tilde is like, it's a shortcut name, but it is a full path, basically. Tilde means, it always means my home directory. So because it always means my home directory, tilde slash means is referring to the home directory. So tilde slash dot bash rc is dot bash rc in my home directory, always. It doesn't matter what the current directory is. So now I'm editing that dot bash rc file. I go to the end. We can see here I've got export path equals, and so this is how I've configured this node path variable, which we can see has a value above, right? Here's the node path here. So here I've actually customized my path, and I can extend that customization by putting, I'll put it at the end, colon home, because remember that is my home directory, and so I'm now adding my home directory to the path, and so that's all I need to do. And if I right quit, now the next time I start my terminal, the home directory, my home directory, will be in that path, and I can run eg.sh wherever I am in terms of, regardless of the current directory. So that's how you customize stuff. And the same thing can be done for adding an alias. So if I type alias, I get a list of the current aliases, and I can do alias foo equals, let's do single quote echo hi there, close double quote for the hi there, close single quote for the whole echo command, foo, and I get hi there. And if I want to make that permanent as well, then I have to edit the .bash rc to do it. .bash rc, and if I look for alias, we can find there are other aliases here as well, and so that's how these are added. Right, these custom aliases were done like that, and so I could do it right at the end if I want. Alias foo equals single quote, then echo double quote hi there, close double quote. So the single quote is capturing all of the command that's going to be aliased, and double quotes just for any funny like string values. Okay, and I can quit out of that. So that's how you customize your environment. You can add aliases, and that's how you can also extend the path environment variable to make programs available from whatever current directory you're in. Okay, now something that's worth your knowing is, let's say you're running a program and it's giving you a large output, like it's logging out to the terminal some text. So just like how EG gives me this message, I can now pretend that was like 100 lines of noise or 100 lines of information. I can redirect that output to a file, and then I can look at that file later on. So the point is that if you're getting these lots of messages and you need to find out what that message is saying, you might be getting, let's say we're doing something with JavaScript, we're using the tools like npm, and you're getting an error, and you need to find out, well, what is that error? And you need to send it to someone to get some help. Like you need to send it to me, or maybe to Inday. So you can use redirect. You can use piping and redirecting to do that. So I can type eg.sh and use greater than to redirect it into a file. So if you think of the greater than being into, right, I can put it to say foo.txt, and now the output doesn't come out to the console here directly, it's gone into foo. So I can use cat, there's a program called cat, to just show, I can't remember why it's called cat, I'm sure there was a good reason, but cat, maybe it's catalog, I don't know, but cat will print out the content of a text file. So I can now do cat on foo.txt, and it shows me the content that was just put into that .txt file. So that's handy, because now I have that text file. Obviously I can go back to Finder or Explorer if I'm using Windows, and I can get that text file and I can attach it in an email and say blah 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 is happening, look at this error message, things like that. The other thing you can do is you can take the output of one file and you can pipe it into another file. So we talked about less before, remember the more with more, called less. So now we had, what was it? For instance, a program that generates a lot of content is the env command. Env gives you a summary of all of the environment variables. So if I do that, bang, filled up the screen. Now, let's pipe that into less. And now I can page my way through this detail. Okay, and in fact, when you look at man, we talked about man last time, man on env. Man prints that content out and it actually automatically pipes it through less for you. So when I'm doing this, I'm actually using less. Right, that's less that's doing the paging function. So that piping is a pretty standard thing, and that's the way in Mac OS or in Linux, a lot of tools are built up that way. So they actually do composition in programs in the command line. Okay, so we've now talked about piping, we've talked about redirecting. And less is one of the things you'll probably be using for piping most often if you're dealing with large content. The other thing that's worth talking about is, okay, it's got a funny name and it's called globbing. That's not important. We can call it file, it's wildcards in file names. So let's go to /user/bin, which has got a large list of programs. I can say, let's say I want to find all of the programs here that start with the letter M. Right now we can see a bunch of them here in front of us, but if I just want to list them using the list command, I can do M star, right? And star means any number of characters after the M, give me all file names that start with M and have anything after it. So if there was a file here just called M, it would include that as well. So 0 characters or more, more than 0. And so here we're getting now make and man and mandb and all sorts of other things. Okay, now that's useful of course, because if you have a large directory with lots of files in it and you might want to see something, you can use this star to identify things. You don't just have to use it at the end. You can use it at the start and at the end, and you can obviously then mix things up with file name extensions as well. So for instance here, I can use this to, I can find everything ending in M just by doing ls star M rather, right? So that would be any letters with M on the end, and there are a few of those. I can also find something that starts with one letter and then ends in another letter by just putting star in the middle. So I can do ls, let's say M star M, oops, lowercase m, and there's only one thing that has an M at the start and at the end. So this is useful for being able to sort of really create patterns basically to identify files or directories, right? That works for files and directories. Okay, the other thing is user bin, or actually if I go back to the parent, at ... in here we'll find there are a number of directories and they have a number of directories under them. Now what we can do, let's say I want to explore all those directories and I want to get them all listed at once. If I do ls, it's not going to happen. Now I can do a -r option. It has to be minus capital R, and that's going to be enormous, right? I can do that. But because that is enormous, I might want to trim that down. And so there's a program called find. So I can do find, and I can give it a starting point, which is current directory, or I can give it another starting point, which might be bin. So that's just saying where to start finding from. But let's start from the current directory. And then I can give a couple of options. I can do -type and say D for directory, or F for file. So if I say directory, now I can just get a list of all the directories from this point on. Turns out there's still quite a few. And of course I can pipe that through less, so I can work my way through that at a more leisurely pace. The other thing I can do is I can also give a name specification, minus name, and I could say let's look for directories that start an M. So now I can't just do M star, because what will happen is it tries to expand that in the current directory right now. It's something that happens in bash. So I have to say M \* star, and what happens then is that star, instead of being expanded right now, it becomes, it's shown to the find command as a parameter. It's basically, I have to protect the star. If I do this, bash will expand it right now. It'll look for anything starting with M in the current directory, and then that will become a parameter going into find, and that's not what we want. We want to have M star as a parameter going into find, so I need to put a \. But if I do that, now I just get any directory that has an M at the start of it. Okay, so if I break out of that, we can see it's M star, right? Yeah. So like Microsoft, so because there was a directory with M anywhere in this relative path, it got listed. So that's what's happening there. So that's quite useful, the ability to look for files or for directories and to give it a pattern. And you can do that with files as well. So we can do find dot minus type f for file. I can look for files that say start with Z, so minus name Z first, and then \* star to protect the star from being expanded right here. And then it turns out there's a few files with a Z at the start, and it's still going. There we are. So that is another utility that could be pretty useful. Okay, we're almost done. Excuse me. Let's go back to my home directory. Now, let's say I want to find any file that has a certain pattern inside it. So let's do a less on package.json, and we know it's got, for instance, well, CLI appears in here. But let's say I didn't know that, and I wanted to find any file that has that. I can use a command called grep. So I can say grep, and then I can say the pattern I'm looking for, and then I can just say star. And so that will take all of the files in this directory, in the current directory. So remember, bash will expand that and make them into a list, and then it will feed that into grep. And grep has found everything with CLI in it. So we've actually got package.json does and yarn-lock does. And so it lists the file name, and it even gives you a sample to tell you where that is. So grep can be quite useful. So say if you've got, again, a large list of files, and you want to find, where's this word? I know it's here somewhere, but which file has it? That's what you use grep for. Now, just to prove to you that the star is expanding in the current directory, I can do echo star. And you can see that star being a way to say all of the files in the current directory, it gets expanded into a list and then fed into the command. So echo sees that, and I can do echo, let's say O star, and now echo just is given a list of the files starting with O. So it's just good to know that. That can be a little bit of a trick, and that's why if I want the star to feed through to echo, I need to put the \. See, and that gets O star without without having it expand first, which is why with the find, why I was saying that before, you need to put the \. in. Okay, but that also means that if I want to just get a list of what's in the current directory, I can use echo star to do it. That's the same as just doing ls. Okay. Now, the last thing I wanted to show you guys was zip and unzip. So Linux and Mac give you a zip utility that just, it's built in. It's one of those programs under /userbin. Let's see which, and if you can't find it, or if it doesn't seem to be there, you can use which to prove that it's there or not there. Which zip, and yes, it's definitely there. Which unzip, that's definitely there. So let's go back into our tester, and let's, in fact, we could zip the content of tester, right, quite easily. So basically I can do zip, let's say I want to take the contents of tester and I want to create a zip file in the parent directory, and I'll call it td.zip, right? So zip takes the zip file name first and then the content. So I can do zip dot for the parent directory /td.zip. So that's the zip file I want to create. And I can say star, and if I do that, we can see it's captured some things, and it's saying how much it's stored, or how much it compressed it. But we can see here subdir doesn't look like it's got any content of subdir. If I do an ls on subdir, it's got a directory in there, and that hasn't been picked up. So if I do a zip --help, we can see that I can do a -r option on it. So let's go up to find that command that I just did, the zip, and if I do let's say -r on the end, now it's picked up everything. So that's a way that you can create a zip file. You can zip up your content. So if you've created a JavaScript, like a Node project, and you want to save it, you want to archive it or back it up, or if you want to make a zip file so you can then send it to, say, for submission, then you can use zip in this way to do it. And then if you want to unzip it, so if I do an ls.star.zip, we can see, yes, there's the zip file that's been created. I can do unzip -l to get a listing of what's inside that zip file. td. Right, and it's just listed it and told, very pretty way of listing it all. It's very very informative. Now let's say I don't want to unzip it here because I've already got that content here, right? It's just going to overwrite. So let's make a new directory in the home directory and call it, we'll just call it test. So I'll make test, cd into test, unzip td.zip, and it's recreated all those files. So you can zip and unzip from the command line. So there we are. That's all I wanted to share with you. Thanks.